Hi, and welcome to this episode of Madison's Chemistry. Today we're going to be talking about intermediates and catalysts. So, this is going to be a continuation of the last video. So, we're going to look at this expression, and first we're going to figure out what it means to be an intermediate. So, intermediates show up first as products, and then second as reactants. So we can see here that B is going to be an intermediate because they are consumed in the reaction, and first show up as products, second as reactants, which is going to be opposite of catalysts, which we'll see in just a minute. Okay, so when we're writing our rate law expression, we can not include intermediates. Okay, so this is important. So, I actually switched this. I wanted to do slow and fast because it's a little bit more interesting. Okay. So if we were to write out what we think this expression would look like, we could say something like rate equals K times B times C, right? Because we learned in the last video that it's always just going to be the two reactants of the slow step. But we just learned this important piece of information that our intermediates cannot show up in our rate law expression. So what are we going to do about it? So we have something we can do. We have another B showing up in our reaction. So we can just equate this to A, which is a reactant. So we can actually say that because one B, not boron, these aren't actual elements, my bad. Okay, so we can say that 1B is equal to 2A, right? So we can actually just say that it's going to be K times A squared, and we keep the C. So we're just going from including B to now including A squared. And there is some math you could do to solve this instead, but I'm not going to go over that in this video. Okay, so yeah, that's what an intermediate does. And that's how you would go about solving for the rate law expression of if it has an intermediate present. Okay, so now we're going to go over catalysts. So catalysts, what do? They increase the rate of the forward and reverse reactions. They do not alter or increase the amount of product made. So one way that you could be tricked on a test, I say tricked, really it's tested for understanding. One way that a professor could ask this on an exam is say, if you add a catalyst, would this affect, or would this shift your reaction towards products in equilibrium? And the answer would be no, because we know that catalysts don't increase the amount of product made, rather they just increase the rate that products are made. They're not increasing the amount, they're increasing the rate, and that's an important distinction, and I hope you guys understand that. Okay, so now let's go over what a catalyst would look like if it appeared in a reaction. So, and then E plus F goes to form B plus maybe D again. Okay, so a catalyst is something that's going to show up as a reactant first as a reactant, and second as a product. And say that this here is our slow step, and maybe let's add a coefficient to make this more interesting. say this is our slow step. If we wanted to turn in the rate law expression for this, it would be rate equals k times e squared times f. So an important distinction between intermediates and catalysts is that catalysts can be included in the intermediate or in the rate law expression. And just to recap information that we learned in the previous video, remember that these are both elementary steps, and together it makes up the mechanism of the reaction. So same with up here, these are both elementary steps, and they make up the mechanism of the reaction. Okay, so I hope that this video helped you in understanding the differences between intermediates and catalysts, and that you can use your knowledge to now apply it to future practice problems. So if this video was helpful, it would be awesome if you could subscribe and give it a thumbs up. Have a good day.